Today we are going to discuss the universal gates, NOR gates and NAND gates. So first we can start with the NOR gate. So a NOR gate is a combination of OR gate and the output of OR gate is given to the input of NOT gate. So we will get the NOR gate. The output of NOR gate is the complement of OR gate. അതായത് OR ഗേറ്റിൻ്റെ ഔട്ട്പുട്ടിൻ്റെ നേരെ കോംപ്ലിമെൻ്റ് ആണ് നമുക്ക് NOR ഗേറ്റിൽ കിട്ടുക. ഓക്കെ, input A, B and output Y. So this, the logical or Boolean expression is Y is equal to A or B complement. Truth table of a NOR gate is like this: 1 1. These are the different combination of inputs, and the corresponding output are for 0 0 it is for NOR gate it is 1, and here for 0 1 it is 0, 1 0 it is 0, and 1 1 also it is 0. That is A or B. For OR gate it is 0 0 0, for 0 1 it is 1, 1 0 has output 1, 1 1 has output 1. So this is the complement, the NOR gate is the complement of the OR gate. Okay. Now, so we have seen the symbol of NOR gate. This is equivalent to a OR gate and a NOT gate. So this is OR, this is NOT. So the symbol of NOR gate is like this. Now how to construct a NOR gate using transistor, two transistors in parallel. Collector of these two transistors are joined together. It is connected to a positive voltage plus VCC 5 volt through a through a resistor RC. Okay, and the input A and B are from the base of the transistor. So this is the simplest circuit for a NOR gate. So we can draw the input and output of the NOR gate. So first we give 0 voltage, 0 for both A and B. So that means we have to connect to this terminal A and B to the ground. Okay, so then this is 0 0. So the corresponding output for the NOR gate, that means A or B complement. So when it is 0, the transistor T1 is off state and T2 also off state. No current flows from the collector to emitter of the first transistor as well as second transistor. There will not be any current flow through the resistance RC. So we can put this as a point, some point K. Okay, so output is connected here. The output Y is equal to, both are not conducting, therefore these 5 voltages will be there in the output. So output will be 5 volt. Okay, next is we give A 0 volt and B 5 volt, that means 1. Okay, then when B is 5, so the second transistor T2 will conduct, that means so current flows through the transistor, second transistor, from collector to emitter. Okay, so this point K is grounded, that means current flows through this resistance RC. So this voltage is dropped across, the 5 voltage is dropped across RC. So because of that, due to that, the point Y, the output Y is 0. Next combination is for A 5 voltage and for B 0 voltage. The transistor T1 conducts, that means transistor T1 is in on state while T2 is in off state. So anyhow the current flows through this, total voltage at Y is 0. If both A and B are connected to plus 5 voltage, that means we have to connect it to a battery. of 5 voltage. Then what happens? The transistor T1 and T2 are in on state. Both are on state. So therefore point K is grounded. That means the current is flowing through the resistance RC. So here also, in this case also, the output Y is 0 volt. Okay. So this is the working of NOR gate. So NOR gate is constructed using two transistors connected in parallel. Common terminal of the collector is connected to the plus VCC through a load resistor, and we get the output from the common point. NOR gate is called universal gate, or NOR gates are called universal gates because using NOR gate we can construct all other gates. Now how this is called universal gate? So we can see that. First let us see how to construct a NOT gate using NOR gate. We have a NOR gate. Now how to make it a NOT gate? A and B. So here we have two inputs. These two inputs are joined together, and the common terminal of this two input is taken as the input A. Okay, and this is so for both the input, whatever voltage we give to A, so that will be there in the both inputs. So this is equivalent to a NOT gate. So here in the output we get a complement. So we can verify using truth table. Next is OR gate using NOR gate. We can construct OR gate using different NOR gates. For that we can take a NOR gate. നമുക്ക് OR gate ആണ് വേണ്ടത്. ഓൾറെഡി NOR gate ആണ് നമ്മൾ ഉപയോഗിക്കാൻ പോകുന്നത്. NOR gate എന്ന് പറയുന്നത് OR gateന്റെ കോംപ്ലിമെന്റ്. അപ്പോൾ ഒരു പ്രാവശ്യം കൂടി കോംപ്ലിമെന്റ് ചെയ്ത് കഴിഞ്ഞാൽ കോംപ്ലിമെന്റ് ഓഫ് കോംപ്ലിമെന്റ് വിൽ ഗിവ് ദ OR gate. ഓക്കെ, അപ്പോൾ ഒരു പ്രാവശ്യം കൂടി NOR gate എടുക്കണം. അപ്പോൾ എന്ന് പറഞ്ഞാൽ അപ്പോൾ ഈ NOR ഗേറ്റിൽ ഒരു നോട്ട് ഗേറ്റും കൂടി ഉപയോഗിച്ച് കഴിഞ്ഞാൽ വീണ്ടും അത് എന്താവും? OR gate ആവും. സോ we are putting one more NOR gate in series. Okay, so A, B, and this is Y. Okay, so here the output of first OR gate NOR gate will give the complement of OR gate. We are making one more complement, that means NOT gate. We are connecting a NOT gate in series, then we are getting a OR gate here. Okay, so we can verify this also. You can verify using truth table. Okay, so we are getting a OR gate using. Next, the third one is we can construct an AND gate. Okay, so we can put this as x1 and x2, or we can verify this thing that AND gate, sorry, it works as a AND gate. So A, B, x1, x2, and so first 0 0, A is 0, B is 0. Okay, so in that case x1 is 0 0, therefore x1 is 1, x2 also 1, because it is a NOT gate, actually NOT gate using NOR gate. Okay, and when this is both are 1 1, then we should get here for a NOR gate it is 0. So AND gate is constructed like this. So first we have to take a NOR gate as a NOT gate and two NOT gates, and the output of these two NOT gates are connected to the input of a NOR gate. So this is a AND gate. Okay, so this is why a NOR gate is called a universal gate. Let's now move on to explain the NAND gate. Okay, so the NAND gate is the combination of AND and NOT gate. Okay, the symbol of an AND gate is so this is the symbol of an AND gate. Okay, this is equivalent to the combination of an AND gate and a NOT gate. Okay, so an AND NOT. So this gives a NAND. Now Boolean expression. Boolean expression of AND gate, sorry, NAND gate is the output Y is equal to A and B complement. The construction of a NAND gate using diodes and transistor. Construction of NAND gate using diodes and a transistor. So the circuit diagram for the NAND gate is like this. So first we wanted to construct an AND gate as explained before. Diodes D1 and D2, the P sides, P region of these two diodes are joined together and disconnected to a positive potential through a resistance, okay, R1. Now this is the output Y of the AND gate. Now it is given to a NOT gate. So NOT gate is constructed using a transistor. It also we have discussed already. Transistor. The base is the input, okay, of the NOT gate, and let's say collector resistance. This resistance is RC. This also connected to the plus 5 voltage. So plus 5 volt. Emitter is grounded, and this portion is the output of the NOT gate. That is the which is the output of the NAND gate. Okay, so this is input A and input B. So each n side of the D1 and D2 respectively are the inputs. The collector of the transistor is the output of the NAND gate. Now let us see how the NAND gate works. When the voltage 0 0 is given. So first we wanted to, before that we want to discuss the truth table. You know, truth table of NAND gate is complement of truth table of AND gate. A, B, 0 0 0 1 1 0 1 1. These are the different combination of inputs, and the output Y equal to. So before we can put what is the, we can include what is a AND gate, A and B. So this is AB complement. So if it is A and B, only the output Y will be 1 only if all the inputs are high. That is, for this combination only 1. For all other combination of inputs, the output is 0 if it is AND gate. Now for a NAND gate, it is just the complement of this thing, 0, then the complement is 1. For 0 again 1 1. For 1 it is 0. So this is the truth table of a NAND gate. Now let us explain this circuit for these different combination of inputs. So first is 0 0, A equal to 0, A equal to 0, B equal to 0. So what happens? A equal to 0, B equal to 0, both the diodes are forward biased, because here 5 voltage and the N is 0 means we are grounding the A and B. Therefore both diodes are forward biased, so the current flows through this, so it is dropped. So we can imagine a point K here, common point K, which is connected to the base of the transistor. The point K at 0 potential. When it is 0 potential, the base voltage is 0. Therefore, IB is 0. The base current is 0. When base current is 0, transistor is off. When transistor is off, no current flows through the collector to emitter. So through the transistor there is no current flow. So that means no current flows from this collector to emitter. So that means there is no current flow through the load resistance RC. Therefore, at Y, the potential will be 5 voltage. Okay. So we got the first output. The combination 0, 0, we have output 1. Next, when A equal to 0, B equal to 5 voltage. Okay, high voltage. For B, 1 means high. That means for a positive logic, 1 is 5 volt. When this is the combination, here also, because since A is 0, the diode D1 is forward bias, therefore K is at a 0 potential. K at a 0 potential. Okay. Transistor off state. Off. Therefore, Y is equal to transistor off means there is no current flow through RC. Therefore, no voltage drop. Therefore, Y is equal to 5 volt. Okay. Next, the third combination is A equal to 0, A equal to 5, B equal to 0. Because of the second transistor second diode D2, this D2 will conduct. Okay, 0, 5. Therefore, it will conduct, and current flows through this resistor R1. Therefore, the point K is grounded. That means 0 potential. No current flows through the transistor for Y equal to 5 volt. When A equal to 5, B equal to 5 volt. Then K is, both are 5. It will not conduct. Both the diode will not. Here also 5. This side also 5. For both the diode, there is no forward biasing. That means current will not flow through the diode. Therefore, the point K is at a 5 voltage. എന്താണ് ഡയോഡ് D1ഉം D2ഉം കണ്ടക്ട് ചെയ്യുന്നില്ല എന്ന് പറഞ്ഞാൽ കണ്ടക്ട് ചെയ്യുന്നില്ല എന്ന് പറഞ്ഞത് കണ്ടക്ട് ചെയ്ത് കഴിഞ്ഞാൽ ഗ്രൗണ്ട് ആക്കുകയാണെങ്കിൽ മാത്രമേ കണ്ടക്ട് ചെയ്യുള്ളൂ. കാരണം ഇവിടെ 5 വോൾട്ട് നമ്മൾ ഈ സൈഡിൽ കൊടുക്കുന്നുണ്ട്. കണ്ടക്ട് ചെയ്യാത്തതുകൊണ്ട് ഈ റെസിസ്റ്ററിലൂടെ R1 കറണ്ട് ഫ്ലോ ചെയ്യില്ല. ദിസ് K ഈസ് അറ്റ് ദിസ് 5 വോൾട്ടേജ് പൊട്ടൻഷ്യൽ. ബിക്കോസ് ഇവിടുത്തെ ഗ്രൗണ്ട് ചെയ്ത് കഴിഞ്ഞാൽ നേരെ കറണ്ട് ഇതിലൂടെ പോകും. ഗ്രൗണ്ട് ചെയ്യാത്തതുകൊണ്ട് ഇത് 5 വോൾട്ടിലുണ്ടാവും. ഇത് 5 വോൾട്ട് ആണെന്നുണ്ടെങ്കിൽ ബേസിൽ 5 വോൾട്ട് ആണ്. സോ ട്രാൻസിസ്റ്റർ ഇസ് ഓൺ. ഓക്കെ, ട്രാൻസിസ്റ്റർ ഓൺ സ്റ്റേറ്റിലാണ്. ട്രാൻസിസ്റ്റർ ഓൺ ആണെന്നുണ്ടെങ്കിൽ കറണ്ട് ഫ്ലോ ചെയ്യും. ദർ വിൽ ബി കറണ്ട് ഫ്ലോ ത്രൂ ദ ട്രാൻസിസ്റ്റർ ഫ്രം കളക്ടർ ടു എമിറ്റർ. ഓക്കെ, കറണ്ട് ഫ്ലോ ത്രൂ RC, resistor RC. Therefore, the voltage 5 voltage will be dropped across RC, that is minus 5 volt. 5 minus 5, the potential at Y is equal to potential at Y equal to 0 volt. So we got this. Okay, this is how at NAND gate works. Next is this NAND gate is also called universal gate. Okay, because using only NAND gate we can construct all other gate. Okay, first let us see how a NOT gate is constructed using AND gate. NOT gate is constructed using, so let us take a NAND gate. Okay, so this is a NAND gate. Join the two inputs. Okay, so this is a NOT gate. So here only one input is there because we have joined this together. So A and output Y. So when we give a 0 voltage here, both input of this NAND gate is 0. Therefore, we get 1 here. Okay, when we give 0, both, if it is 0, this also, both input of this NAND gate will get 0. Therefore, the output of a NAND gate will be 1. Okay, now next is, if we give 1, both input will have 1, therefore output will be 0. If we give A 1, then output Y equal to 0. Therefore, this is a NOT gate. Next is AND gate. We know NAND gate is the complement of a NOT gate. NAND gate will give the complement of NOT gate. So we will give one more, we'll put one more complement to that, then, or we will invert that NOT gate, NAND gate, then we'll get AND gate. So how is it done? So this is NAND gate, okay, and we put one more NAND gate, A, B and Y. So here the output of this gate will be like this, okay, A, B. So let me put this as X and this is Y, okay. So first output of the NAND gate is X and the final output is Y. So which is the, okay. So the combination of inputs are 0 0 1 0 0 1 1 1. So when 0 0, what happens? The output X is equal to 1, okay, and the output Y is equal to, if it is 1, the output will be 0. Then next, so it is better to keep this in the ascending order, okay. So this is 0 1 1 0. Therefore the output of this thing NAND gate will be 1. Therefore Y is equal to, Y is again one more NOT gate, this is NOT gate, therefore it will be 0 1 0. Also output X is 1 and Y is equal to 0. For 1 1, the output X is equal to 0 because it is a NAND gate, again one more NAND gate which is the NOT gate, okay, joined together. Therefore this is 1. This corresponds to AND gate output. So this is how an AND gate is constructed using two NAND gates. Next is the third one is OR gate using NAND gate. So this is also similar to the one in which we have discussed in the case of NOR gate, okay. So we have okay. So the input A, input B, and here x1, x2 and y. So let me draw the output of different combination of inputs x1 x2. So A, B, x1, x2 and y, okay. So when I give 0 0, then when it is 0, here we will get x1 will be 1. When b equal to 0, x2 will be 1. When both are 1, the output y is equal to 0, isn't it? Next is a0 b1, okay. When a equal to 0, x1 is 1. When b equal to 1, x2 is 0. When these two are 1 0, then the output of NAND gate is, again, output of NAND gate is 1 actually, 1 0. So for a AND gate it will be 0, for a NAND gate it will be 1. Next is 1 0. Here it will be 0, here it will be 1, and if it is 0 1, so the NAND gate has 1. Next final one is 1 1, here 1, here 1. So x1 is 0, x2 is 0. Okay. If both are 0, then AND gate output will be 1. So this is equivalent to a OR gate. So we got an OR gate. See, if any one of the input is high, then output is high. So this is how an OR gate works. So that this is why NAND gate is called universal gates. Using NAND gate and NOR gate, we can construct all other gates. Okay, either NOR gate or NAND gate you can use for constructing all other gates. Okay, this is for today. Thank you for watching. Okay, let's see in this next class. Okay, thank you.